So welcome to the another video in the compendium of limits. In this we are going to solve a problem that was asked in CMI 2021, and this is just about limits. So let's talk about statement A, in which you have to calculate limit fx at 0. So limit x tends to 0, fx, that is x upon x plus sine x. Okay, and we can see that it is a 0 upon 0 form, so we can use L'Hopital also, or we can use expansion also. L'Hopital is easier, so I'm going to use that. So at using L'Hopital, it becomes limit x tends to 0, and this is 1 upon 1 plus of cos x, and this is at 0, this is 1 by 2. So statement A is true statement. Okay, now let's talk about statement 2, and it is limit x tends to infinity, and it is fx, that is x upon x plus of sin x. We can see that this is infinity upon infinity form. Okay, so what we can do is we can see that the sin x is oscillating between -1 to 1. Okay, for every value in the interval infinity. So what I'm going to do is I'm going to divide it by x in order to create this. Sin x upon x will be then 0, so I'm going to do that. So this x, so dividing numerator by x gives us 1, and dividing denominator by x gives us 1 plus sin x by x. Now this thing, sin x is a finite number between -1 to 1, and x tends to infinity, so this whole thing tends to 0. Therefore limit tends to 1 upon 1, that is 1. Okay, so statement second says that it does not exist, but it exists, and it has a finite value, so this is a false statement. Let's talk about statement 3, which is limit x tends to infinity, gx, that is x to the power 4 plus x to the power 6 upon e to the power x minus 1 minus x square. Okay, so we can see that this is actually infinity upon infinity form. This is what? Infinity upon infinity form. We have to differentiate using L'Hopital 6 times. So ultimately what we'll have is, we'll have this thing, we'll have 6 factorial upon e to the power x, because derivative of e to the power x every time is e to the power x. Okay, now numerator is a finite value, but e to the power in x, when x tends to infinity, is infinity, so this tends to infinity, and numerator upon a finite value upon infinity is 0, so this tends to 0, and it's a finite value, so statement C is also correct. Let's talk about statement D. In statement D, we says that limit x tends to 0, gx, that is x to the power 4 plus x to the power 6 upon e to the power x minus 1 minus x square. This is 0 upon 0. Okay, so we have to differentiate it using L'Hopital. So let's see what we are getting using L'Hopital. Using L'Hopital, we'll get limit x tends to 0, and this will be 4x cube plus 6x to the power 5, and in denominator we will have e to the power x minus of 2x. Okay, now at 0, this is not 0 upon 0, so numerator of 0 here also, but in denominator we have 1. Okay, so the answer would be 0. So the answer of this particular limit will be 0. So I think this is a false statement. So we can see that statement A and C are only true, and D, this is false, this is true, this is false, and this is true. So that's an easy problem. I think this would help. So please like, share, and subscribe. Thank you.